there's a long plank. Of mass m2. Let this be smooth, let this be rough. I'll give velocity to the block. So there's a rough is having coefficient of friction. So after what time the block will come to rest on the plank, or after what time both will move together, these are the conditions. This is that t equal to 0, this is thing. So what is the thing? A block of mass m1 is kept on long plank of mass m2 and then given a velocity u at t equals 0 as shown. Find the time at which both will move with common velocity. Both will move with okay, something he has he has given a condition. Let's see that. Okay, let's get into the idea. The friction will always oppose the relative motion between the surfaces here. So what is the velocity of block 1 with respect to plank? Will be towards right. So how the direction of friction should act? This is at t equals 0. Then what is the direction of u12? U12 will be like this. Then how the friction must act opposite to u12. I'll give the colors, it'll be much easier. What is the state of block? Plank is at rest here. Only the block is given. So how the friction by the plank on the block should be such that it should oppose the motion. So here, before that, so show me the forces that are acting. So the weight of the plank, m2g. There'll be a normal contact between them. The normal contact n1 and this is m1g. And also there'll be normal contact by the block on the plank, that n1, I'll show it. And this will be m2g. Let's along y-axis. Will the block and plank, will it move along y-axis? No. So therefore, what are the equations? We can write it here. n1 minus m1g equals 0. That is on the block. Look at on the plank. On the plank, there'll be normal reaction by the, this is not needed. Actually, N2 and M2G should act along same line of action. To make the some clarity of the diagram, I'm just shifting it N2. Okay, got it? So N2 and M2 should be along the same line of action. So to make diagram little bit visibility, I'm just shifting N2. Fine. So there should be the now the what is the equation? N2 minus M2G minus N1 equals 0. So N2 minus M2G minus M1G equals 0. So what is N2 is equal to M1 plus M2 into G. Okay, these are the normal contacts that are acting like this. If you keep some 3-4 blocks, now you have to trace out here because the net force on the block or the plank along y-axis is 0. That's why I'm equating them. Okay, now let's come for direction of friction. What is the velocity of block? What is the initial at t equals 0? What is the state of block? Block was at plank was at rest. No, only the block is given velocity. So what is u12? U12 bar should be towards right. The friction by the plank on the block will be in this direction. Is that okay now? Similarly, what is the u21 velocity of the plank with respect to block? U21 in what direction should be? U21 should be in this direction. I'll show it here. In the corner it's available, U21. In what action the friction should be? Opposite to the relative velocity. So the friction on the plank will act in this direction. We have to show the friction at here actually. Actually, the friction we have to show it here. We have to show that friction here. So you'll get confused. That's why I shifted. And the books open that is they shown it here. Okay, no problem. Correct it is. So, so like where the block is not here, nowhere here, how friction to make you understand. It's all about to make the student to understand. Okay, I'm just bringing it here. So if you want, you can show it here, F1. That'll be still more clear. I'll take it out. The F1 should be like this. So you can try this. These are nothing. You take compass box, keep it on table, keep one eraser. That one, just strike the eraser like this. Strike the eraser. If you just strike the eraser, nothing but you are imparting some velocity. Then you can see the situation, what happens. Provided the surface between the compass box and the ground should be smooth a little bit so that the plank can move. Practical open, this cannot be smooth. It should be rough between the plank and the ground. We are discussing some ideal case. This is the initial diagram. Now tell me what will happen to with this. The velocity of block will keep on decrease. And because of this friction force acting, what happened to plank? Plank starts accelerating. So any accelerations can you give? So this will undergo retardation, no? Because the force acting opposite to velocity. And what about this? This will undergo acceleration. Because the force is acting, because of that, it will start accelerating. I'll write only F, because F1 that will get confused. No. What is the acceleration A1? So first we'll calculate the values here, specific values. After some time, anybody, can you tell like what situations will arise? That the plank will no longer will be here, no? Because of this acceleration, the plank will shift. And whatever the block also will shift. So let it come to some position. And then what will happen to the speed of the block? It keeps on decreases. So let it have one velocity. What is the speed of the plank? It will keep on increases. Let it have some velocity. Let it be m2. And at one instant of time, so what happens? Both will have common velocity. This is what that time t. And now you tell me, will any friction will act here? There's no relative motion. No? The friction will not act. This is something very simple problem and very important for us to carry on the further concepts. Why do they acquire common velocity? Because of retardation, the velocity of the block keeps on decreases. Because of acceleration A2, the velocity of plank keeps on increases. At one instant, what happens? Both will have common velocity. The moment no relative motion, there's no relative motion. So what happened to the friction? Friction will vanish here. But sir, they're moving. So we are not bothered moving at rest. If there's no relative motion, the friction will not exist here. Because the friction will always act opposite relative motion. Though it is a rough, though surface rough, still, because there's no relative motion between the block and the plank. Now earlier the block was in contact at point P1. Now you see that after some time, it will arrive at P2. Let's keep these things in the mind, or AB, I'll write it. So very initially the block at point A on the plank. Now finally where it is? At point B. This is just assumption. So is there any displacement of block with respect to plank? Yes, it is. You see also the plank got displaced with respect to initial position. You look at the block also got displaced, no? X1. So what is X2? Displacement of plank with respect to ground. What is X1? Displacement of block with respect to ground. That X1 I'll indicate here. And what is the displacement of plank with respect to, displacement of block with respect to plank? AB. We have to find out all these things. So first, I think I want that velocity and time. How to bring that? Let's go for calculation. So what is A1?
Sir, sir, in this example, would the friction be variable, sir?
Why you are making unnecessary things here? Why it be variable? Kinetic friction depends on what? Mu, m, g. Mu constant, m1 constant, g constant, or no?
Okay, sir.
Unnecessary thinking. Don't make things complicated. Okay, let's go for calculation of A1. So what is A1? A1 should be equal to F by M1. I'll put negative sign, retardation. No? What is F1? F1 is equal to mu N1. What is F? F is equal to mu N1 only. Mu M1G. So substitute this mu M1G by M1, which is equal to minus mu G. What about acceleration A2? F by M2, which is equal to mu M2G by M2. So this will remain as it is, mu m1g by m2, this one. Okay, now I got it. So let's write expression for velocity. V equal to u plus a1t, u minus mu gt. Similarly, looking at the block, looking at the plank, V equal to a2t. So what is value of a2? Mu m1g by m2 into t. So let me equate these two equations, 1 and 2. So equating this, 1 and 2. So I'll get equation for mu m1g t by m2 is equal to u minus mu gt. So the expression for time will be t is equal to, or we'll write one more equation. This will be mu m1g by m2 plus mu g t equal to u. So the expression for t will be u by m2u mu g m1 plus m2. There's a time taken for the friction to vanish. After this time, what happens? They'll continue swimming. How long? As due to inertia of motion, they'll continue that their velocity, their uniform velocity motion. How to calculate all things x1? Once you know the time, you can get all other things. Now substitute this t here to get the velocity. So you can calculate velocity x1, x2, and also the distance ab. What is ab? Displacement of block with respect to where that one. So let me write. What is ab? AB is displacement of block with respect to plank. So that is what x1 minus x2 from the diagram. That is what AB, no? So what is AB is equal to x1 minus x2. How to calculate x1? X1 should be equal to ut minus a1 t square by 2. What about xt? A t square by 2. Do calculation later on. I'm just giving the basic idea. So whenever, if you give velocity to the block, no, there's a one basic condition, what we applied. Okay. Similarly, sir, I'll give velocity to the plank. Yes. Then get the direction of friction acting on the block and the plank with the help of relative velocity. Then see what conditions will arise. I'll just discuss qualitatively. So you work out. Just I'll give only the idea, that one. So here instead of, let me give velocity to the plank, or I'll give velocity for both the block and the plank. What conditions will arise here? This is rough. At t equals 0, this is the situation. So if u1 greater than u2, we'll determine the direction of friction. I'll put a condition later. U1 greater than u2. Then now u12 will be in this direction. then the friction will be like this. U21 will be in this direction. Then the friction will be in this direction. So then after some time, we get the position of block. Both will have common velocity. This is after some time t. Because it's not that only the I can give velocity. No, sir. Like if u1 less than u2, what conditions will arise? The direction of friction will change. Okay, na? Yeah. Okay, fine. So you try to work out the problem. This also the same thing. And there's a distance AB. What distance the block has moved